Thank you. So first of all, thanks for having me. I'm quite happy to see so many faces so late in the day, because, well, I've looked at the agenda and it's a quite long day, so thanks for coming. So today we're going to discuss serverless Java. So before I start, just by show of hands, who is already using a serverless platform today? Okay, I just see one hand. With Java or JavaScript or something else? JavaScript, okay. Well, that's not what we will discuss, obviously, today. So today I'm going to discuss serverless with Java. Before I start, a few words about me. So my name is Delabassee. You can find me on Twitter under @Delabassee. I live in Belgium, and I work for Oracle. So I'm part of the serverless team at Oracle. So I'm reporting directly to HQ. And before we talk about serverless Java, I think it's always useful to give some context about me. So I'm coming from Belgium. Belgium is a very small country. I think it's like, so the number of inhabitants of Belgium is like 3 times smaller than the number of inhabitants of Poland. Poland, in terms of surface, is like 10 times bigger than Belgium. So Belgium is basically a very small country. But we do have one thing that is very famous. That's basically the Belgian cuisine, the Belgian food. So Belgian cuisine, what do we have? Belgian beers. We have like 1,600 different types of beer. And in fact, Belgian beers have been put by the UNESCO on their cultural heritage list. So that's something which is very important for us. We then have the best chocolate in the world, the Belgian chocolate. And then there's this. Anybody has a guess what this is? Fries. That's a good point. Wherever I go, people tend to say French fries. And clearly, fries are not coming from France, but they're coming from Belgium. And in fact, if you go on the Wikipedia page of fries, assuming that you have a lot of time, there is a whole section that basically goes over the battle between Belgium and France. But clearly, we have all the argument on our side, and fries are coming from Belgium, not France. And then there's this, Brussels sprout. Anybody enjoys Brussels sprout? Whoa. I see 5 hands. I'm really sorry for you. And in fact, I have my own theory about the sprout. I'm pretty sure that the sprouts are not coming from Brussels nor from Belgium, but they're coming from France. So Belgium is also the land of surrealism. And in fact, to come here, I took a Brussels Airlines, which is the Belgian national airlines. And they happen to serve fries on flight. So I'm pretty sure that it's one of the very few airlines that serve fries, Belgian fries, on flights. And if you look closely, they also confirm that fries were actually invented in Belgium. So anyway, enough with the Belgian cuisine. So let's talk about serverless and serverless Java. So before I talk about the Java side of it, I just want to set the stage. So I will give you a very short introduction about what we mean by serverless, what we mean by FaaS, function as a services, so that we are all on the same page. And then we will see basically serverless Java in action. So first, there is these ongoing discussions regarding the serverless name. Yes, it's a very bad name because yes, there are a lot of servers. And there is this very famous blog post that basically says that serverless is just a name, so get over it. When they picked that name, they could have called it something completely different, like Jeff. And in fact, there are a few Jeff conferences that are focused purely on serverless. So forget about the name. Yes, there are servers. It's just a name, but it happened that's the name that everybody is using, so we are also using that name. So serverless, yes, there are a bunch of servers, so we all agree on that. Then, function as a services. So first, in any serverless platform, we have the fundamental unit, which is a function. A function is basically a very small piece of code that has one job. So it's a very well-bounded piece of code that will perform one task. Most of the time, the function will have some kind of input, and most of the time, it will produce some output. Now, it's not necessarily a function as we have in Mathematica, in the sense that a function can also have some side effect, like, for example, putting something in a queue, those kind of things. Those are typically side effects. So we have this notion of a very well-bounded piece of code, and that's basically what you, a FaaS platform user will write. So you will just focus on writing those functions. And then we have this as a services piece, which is basically the compute element on which your function will be deployed and run on. And if we're looking at the serverless space, there are two kind of roles. There's the FaaS platform users, you, and there's also the FaaS platform provider. AWS Lambda is a FaaS platform provider. Azure is one of them. Oracle will be one of them. And the main idea with a FaaS platform is that at the end of the day, you, the FaaS platform user, will just focus on writing your function and deploy your function on the platform. And all the management of the platform will have to be done by the FaaS platform provider. So you, as a user, will not have to take care about patching, making sure that everything is patched at the right security level, provisioning, making sure that you have enough server to basically cope with the load that your function will get, and so on and so on. So you, as a developer, will just focus on writing function. And then there's a whole work that will be done by the FaaS platform provider, which is basically the low-level dirty jobs of making sure that everything works, everything is patched, and everything is scaled to meet the need of the users. So we have those two pieces. So the main idea with the FaaS platform is that we have function, and function are basically the fundamental element. Fundamental element of design, you will write function. Fundamental element of deployment, you will deploy function. But the function will also be the fundamental element of billing, because at the end of the day, you will be charged when your function will be run. And one of the key ideas that we see with FaaS platform is that basically a FaaS platform provider has the ability to increase the density of its architecture, of its platform. So that means that basically all the cost saving that the FaaS platform provider is making should be reflected on what you will pay at the end of the day. Typically, when your function is not running, you shouldn't pay. Obviously, if your function is running, you will pay, but you will just pay for the execution of your function. And obviously, if your function is invoked a lot, you will have to pay accordingly. But that's okay, because at the end of the day, if your function is invoked, that also means that we can expect that on the business side, you are doing good. So, why serverless? Why serverless? There's no server to manage. That's really one of the key aspects. Scaling is something that should be provided by the platform. How this is achieved? Typically, the function will be stateless. So you shouldn't hold any state within your function. And that's basically what enables the FaaS platform provider to scale the function to meet the demand. In terms of billing, you only pay for what you use, what you consume. It's basically a pay as you go. So if your functions are not run, you don't have to pay anything. And also, one of the key aspects of serverless is that it basically improves your agility. You will see that if you are focusing just on writing your function and deploy your function, well, you can really spend most of the time on tackling the business aspect of what you want to achieve. You don't have to deal with all the underlying aspect of managing a platform. So that's basically, in a nutshell, in 2 minutes, what FaaS and serverless is, function as a services. So some time ago, at Oracle, we started to look at that space. And we introduced a project, FN project, which is an open source FaaS platform. Now, you will see through the presentation that given that everything is open source with FN, you can take FN and run it on premises. Or you can also run it on your laptop. That's what I'm doing here. This is very convenient when it comes to development. Obviously, if you are doing that, if you are running FN, which is a FaaS platform, if you are running FN on premises, that basically means that you are losing one of the benefits of a FaaS platform. You will have to manage that platform. But that's okay. I mean, if you acknowledge that, there are some use cases where it makes sense to run a FaaS platform on premises. Like, for example, if you don't want your data to leave your data centers, or if you have very strong regulation that basically forbid you to do certain thing, then you can still write function on top of a FaaS platform. But obviously, if you are doing that in your home data center, you will have to manage the FaaS platform by yourself. And obviously, at some point in time, Oracle will have a managed version of FN, so basically services that you can buy if you don't want to deal with the management of the platform. But again, everything is open source, so you can take FN and you can run it on any cloud provider. That's something which is perfectly possible. So when we started to work on FN, we basically set ourselves some goals. So what do we want to achieve? So first, we don't want to have any vendor locking within the platform. If you're looking at most of the solutions today, they are all locked to one single vendor. And given that we are relatively late in that game, if we want to get traction, we need to make sure that there's no lock-in. Lock-in to Oracle, but also no other lock-in to any other potential vendors. Everything is open source, so I think that we have lifted basically all the locks. So FN should be approachable. So you will see that to get started, it's very easy. All you need is to have Docker running on your machine, and you can already start to write and deploy function. So it should be very, very approachable, but we also want to make sure that we give the right capabilities to advanced users. So more complex things are possible in FN too. It's not something that is hidden or forbidden. You will see through my presentation that FN is leveraging containers. So basically in FN, any function is a Docker containers. And this provides us many benefits. You will see some of those benefits through some of the demos that I will do. FN is also scheduler independent. So we at Oracle have made the choice for Kubernetes, but there's nothing that is baked into FN that strongly linked FN to Kubernetes. So if you want to take FN and run it on a different scheduler, that's something that is perfectly possible. We also have a very strong focus, and we want to make sure that FN is very attractive to developers. So that's why since the beginning, we have this notion of being language independent. So technically, FN is written in Go, but you will see that Java is a first-class citizen in FN. And the idea is that, well, if you are a Java developer, and if you want to write function, well, if we are telling you, okay, you can write your function using JavaScript, there's a mismatch. On the other hand, if you are a Node developer, and if we are saying, okay, we have a very strong Java support, so write your function using Java, again, there is a mismatch. So you will see that FN basically supports a bunch of language. And if that's not enough, you also have the ability to add your own language. And last but not least, FN is platform independent. So FN run in the cloud, that's really the end destination, the final goal. So we want to have a managed version of FN. But as I already said, you can also run FN on premises or on your laptop, something which is very convenient for developers. So, introducing FN function. So we already said that a function is basically a piece of code, a well-bounded piece of code that gets something in input and will provide an output based on that. In FN, all the functions are wrapped into a container. So all the functions are basically Docker image. You don't have to write those Docker image. So FN will basically take your function and wrap it using its tool in a Docker image. So the only thing that you will see basically at the end of the day is your function. Now you can take any application and basically turn that application into a function. Because any application that supports std in for the input and std out for the output will be turned into a function. Now there are benefits to use what we call FDK, Function Development Kit. So FN provide different function development kit that will provide additional benefits. And I will go over some of those benefits when I'm going to talk about the Java function development kit. So just keep in mind, in FN, a function is basically a Docker image. It's a container. Now, if we look at the architecture, I will not spend too much time on this because at the end of the day, the architecture is kind of hidden. If you're using FN through a FaaS platform provider, you don't really see that. Just keep in mind that there are a bunch of FN servers. And obviously, if we have multiple servers, we need to have a front load balancer to do some intelligent routing of the incoming request. You, as a user, will typically use the CLI. So the CLI it's a command line tool that is basically your gateway entry to FN. You can bootstrap your function using the CLI, you can deploy your function, you can invoke your function, and so on and so on. So this is the main tool that you will use and that you will see today. And obviously, it might also be useful to use some of the FDK that we're providing. Typically, if you are writing Java function, it might make sense to use the FDK. So let's look at FN. So I hope that the font are OK. So what I have here, I have FN running on my machine. So basically, I have Docker, and from there, I've just installed FN, and everything was handled for me. So FN init, runtime. I'm going to use the Java runtime, and I'm going to call this function Duke. So FN is basically the CLI. So here I have used this FN CLI to bootstrap a function. So if I look in that function, there's basically a few files. So there's a func.yaml. Yep, sorry, that's not going to work. So the func.yaml is basically a configuration file that contains metadata for my function. So for example, the runtime that we want to use is the Java one. This is the Docker image that we're going to use. So we're going to use the JDK9 in this case. The CMD is our entry point. The format is something that you don't necessarily need to know at this stage. What we also have here is a POM. So basically, in FN, a function is just a Maven project. And then, well, you know what? Given that it's a Maven project, I will just use IntelliJ. Oops, there. So let's see. So I'll go to the source, and I'll zoom a little bit. So this is my function. So you see this is plain old Java. There is no interface. There is nothing specific to FN here, in fact. There is just a method that, in this case, gets a string. The method is my function. So my function is doing something, and then it produces some output. What I also have here is this. So if we go here, we also have a JUnit test to test our function. That's something that is provided by the FDK. So if we want to run this function, what we need to do, we need to deploy it. So FN deploy. I'm going to use a local. What I'm doing, I will use verbose so that you can see what's happening behind the scene. I'm going to deploy that to the application which will be called JDD, and Duke is my function that I want to deploy. So let's see. So, well, if you know Docker, you see that basically what we have done here, we have used Docker to create the function. So if we look at the command line, so we have these app parameters here, JDD. An application is just a grouping of functions. So it's basically a logical unit that we are using to group functions together. I've used the local flag to avoid that the Docker image of my function is being pushed to my registry just to save a little bit of time. So now my Duke function is deployed within my JDD application, so that means that I can invoke it. So to invoke a function, I can do JDD and then Duke, which is the function itself. And this is the result of my function, which is really something very basic, hello world. Obviously, I have the ability to pipe in some. So JDD, Duke. Sorry, I'm typing to. Hello JDD. Now, you might have not noticed, but the first time when I invoke it, it was quite slow. Because basically, the FN server, so I've deployed my function to my FN server, but the first time there is a request for a given function, the FN server needs to basically boot a container. But it keeps that container hot. So the next time I invoke that function, I'm reusing the container that is already started. So that's why if I'm invoking my function multiple times, you see, or I should have timed it. Oops. You see. So I'm going through the network, I'm invoking my function, and it takes like 100 milliseconds for a Java function. So this is something which is quite good. Everything is running on my whole laptop. So we have a POM. So what we can do, for example, let's see. I can test my function. It doesn't work. Oh, sorry. So obviously I need to be in the right directory. So again, the idea, given that we're very developer friendly, if we're talking to Java developers, we don't want to ask you to use something else than something that you're already using today. So it's basically a Maven project. You can use it to test your function, to build your function, and so on and so on. So what can we do here? Let's see. So this is the function. The function is pretty basic. It gets a string, and it produces a string, something which is a little bit limited. So what we can do this. So let's see. Let's create a new class that we're going to call person. So it's a person. So a person has a, let's see, as a last name and as a first name, right? I need a default constructor. And I need getter and setter. So nothing fancy here. This is just a POJO for a person with a last name and a first name, right? So what I can do here now, I can say that, for example, here I'm returning a string. I can say that instead of returning a string, I want to return a person. So p equal new person. Don't remember. Obviously, this will not work. Return p. I obviously need to change the signature of my function. So this is a person. I'm returning a person. So there's something strange here. Let me check. Get first. Yeah, it should be okay. So this is my function. So let's test this function. So to basically test my function, I need to redeploy the function. Deploy local app JDD Duke. Obviously, I need to either. So the issue here is that I'm saying that I want to deploy the Duke function, but I'm already in the Duke directory. So if I go up, and we have an error. Anybody has a guess why this has failed? So the return value of the function p, no, this is okay. Because this should return a person, and I'm returning a person. Yes, my test, I'm still using the old test. So I can fix the test. Well, I need to fix the test. It's easy to do, given that it's a Maven project. Skip test. Okay, you're not happy with that. What about that? Well, the thing is that if each time I have to fix the test, well, it will take too much time. So you get the idea. So let's deploy it again. So it builds and it's deployed. So now I can invoke my function again. So let's see, echo -n, JDD, the function invoke. So we need to invoke the function to my local server. The app is JDD and the function was Duke, right? Yes. And you see that the result is a little bit different in this case. basically let me do it again. Oops, sorry. Oops. So this is the result of my function. This is basically some JSON payload. And if we go back to the function, you see that basically what I'm doing here, I'm just returning a Java object, a Java person object. So this is one of the benefits that is provided by the Java FDK. Input and output coercion from JSON to Java and from Java to JSON is automatically handled by the Java FDK. So you as a Java developers, you just have to focus on writing Java code, nothing else. Obviously, the marshalling and unmarshalling that the FDK is providing has a default behavior, but you have the ability to override that behavior. And if you look here, I've just basically used output coercion. So I'm just returning Java object. I'm still getting a string in input, but I can also use input coercion. So I can, for example, I can easily say that my input now is a person object. Obviously, if I'm doing that, I will have to pass the right JSON document whenever I'm invoking that function. So this is one of the benefits that is provided by the FDK. Input-output coercion is handled for you. The FDK is also providing the Maven support, including the JUnit test. Those are the kind of things that we are providing to basically help you to more easily write a function. And obviously, given that we are Oracle, we are spending a bit of time on making sure that Java is well supported on top of FN. So let's go back to the slide. So FN has a very strong Java support, but as I already mentioned, it's not just Java. We're also supporting Go, Python, Node, Ruby, and so on and so on. And if that's not enough, given that we are using Docker under the hood, you can also add support for other language yourself. That's something that I did for two languages, Kotlin and Groovy. So if you do fn init, but this time if you said that the runtime is Kotlin, you give the function a name, kota. Now if we look there, so we still have our func.yaml, so all the metadata. But if we look at the source, we have the source of the function, and this is really a Kotlin function. And not only that, if you look at the tests are also written using Kotlin, using the, I don't remember the JUnit module that provide Kotlin test. But this is basically something that is available today. So you can add support for other language by yourself. The way I've added Kotlin, I did that, I think, 6 months ago. So now things have changed. So to add Kotlin support, I had to hack a little bit of Go code to make sure that the CLI support Kotlin. Now you don't even have to code in Go. So what happened is that basically now we are using Docker to generate all the boilerplates of a function. So you can add support for any given language. The only thing that you need to know is a bit of Docker. You also need to know basically how to turn source code for that given language into an executable, which makes sense. And I've done that for Groovy. So if you look here, I'm using the fn init runtime command to bootstrap a function. But we also now have a different way to bootstrap a function. It's called, I think, init image. And you pass it the name of, so it's a Docker image that will basically bootstrap the function. And I think that the function, the one for Groovy is called init, Groovy init. And let's call the function Groovy. So again, if we look at the Groovy directory, we now have a Groovy function. So edit Groovy So this is my Groovy, this is my Groovy function. And I can run it. It's a bit slow because I still have to do a few tweaking. But so now if I deploy, so deploy minus local minus app JDD, and the function is the Groovy one. So let's see. So it's deploy. So now if I, for example, look at all the function that I have within my JDD application, so ls, fn, JDD, I have the dupe function and the Groovy function. So let's invoke the Groovy function from the JDD application. Again, applications are just a logical way of grouping function. And again, well, you see that it works, but let's change the Groovy function. Where is it? So let's redeploy the function, Groovy. And let's call it again. And this time we should have, indeed, we have a different result. So basically you see that with fn, given that we are using under the hood container, it's very easy to add support for any kind of language. So Kotlin is part of fn. Groovy is something that I did as a prototype, but that's something that you can certainly use today. Oops, sorry. So let's quickly talk about state. So I told you that functions should be stateless. That's the only way we can make sure that we can scale. Having said that, there are use cases where it makes sense to hold state within a function. So most of the time, if you have some state, you need to hold that state outside of the function, in a queue or in a cache, and so on and so on. But there are certain type of function that needs to have some kind of states. And that is when you are trying to compose multiple functions together. So the idea is the following. So let's imagine that you have a function that will invoke another function. It will get the result of that function. And based on the result of that function, it will invoke another function, and so on and so on. If you want to do that, then the main function, the upper function, need to have some kind of states. And that's something that we're providing in FN. That's called FN Flow. So FN Flow is, anybody is using the completion stage API of Java EC8? No? So the completion stage API introduced in Java EC8 is an API that had support for asynchronous tasks. So basically, you have a task that will be executed in an async fashion, and when that task is done, the API allows you to easily trigger the execution of other async tasks. So basically, you can define a pipeline of task execution. All of that is done in async fashion. FN Flow is basically the same concept, except that the completion stage, everything is happening within the virtual machine. Here, with serverless function, we are talking about serverless function that happen to be distributed. So it might be that a function is running on one FN server, but it can also happen that a function is running on a different FN server. So it's basically the same concept. It's basically an asynchronous task API. The major difference is that FN Flow is a distributed asynchronous task API. And well, let's see, yes, I will show you a very quick demo. If you have been using the completion stage API of Java EC8, it's very similar. So let's see. Oops. So I have an app that is called My App, I think. So let's see. FN, ls. OK, so in My App, I have two functions, function A and function B. So those functions are very basic. And I will just use one because we don't have much time. So let's see. I will pass something to my function, like test. And then I will invoke my app, the function A. Oops. So basically, the function is taking the payload and it's just had a prefix and a postfix. So let's see, echo n. Oops. Sorry. So you see, I pass test and I get a func A test. So this is the result of my function. It's pretty basic. So let's see. Now I will invoke that function from another function, from the simple flow function. So let's see. It's here. Oops. So this is my function that will invoke another function. The thing is that the API has recently changed. So right now, to invoke another function, we need to have the ID of a function. So this is basically the first line that we have on the top. And then it's just a matter of creating a flow. So a flow is basically a pipeline of function invocations. So we get an instance of the flow. And then, so flow invoke function. So we're invoking the first function. We pass it the payload that we have, and then we are using the then apply function like we have in the completion stage API to basically do something with the result. And the function is just returning the results. So if you look at this function is just taking the payload that it gets, it invokes another function, and it basically sends that back to the calling users. So let's deploy this function. So now let's invoke the simple function. So no, let's call it JDD. If an invoke my app, and the function is called simple flow. And you see this is the result that we have. But this time, we have invoked the simple function that is invoking another function. So it passes the payload from that it gets. It invokes that func A function. It waits for the result. And once it has the result, it sends that back to the users. We can look at that using a simple CLI that we have. So I will invoke the same guy again. And here we are basically seeing the execution of the two functions that we have. So this is the main function. Obviously, the simple function is the longest one because it has to wait that it gets the result from this function. Then we are applying the then apply to do something with the result. And once the then apply is done, the main function can return. So that's basically where it sends back the result to the users. So FNFlow is an API that we have in FN. Right now, we have a Java implementation. That's clearly the most advanced one. We also have a Go implementation. And we're thinking about adding Flow support for other language. But clearly, if you want to work with Flow today, you'd better use the Java one because that's clearly the most advanced one. And FNFlow basically gives you the ability of composing multiple functions together. Again, using an API and not using a design tool like some other solutions do. Visual designing tools are very nice when it comes to demo, but that doesn't really scale. Because the thing that I haven't talked about here is that when you are calling a function over the network, it can fail. So that's something that the API can obviously deal with. So it can deal with remote exception, and it can also deal with the fact that maybe it might be wise to recall the failing function, but we don't want to recall it right away. We basically want to have some backoff time to make sure that we are not hitting the remote server too much to avoid additional issue. So that was basically a very short overview of FN. I'm afraid that we don't have time to cover everything that FNs already provide. For example, right now we're working on adding support for the substrate VM from Graal. The idea is that you see that whenever we are running a Java function, we are getting good results. I mean, the startup time is quite okay. But if we are using the substrate VM from Graal, we can reduce the Docker image size, we can reduce the memory consumption, and we can also improve the startup time of the function, because what we're running at the end of the day would be a native executable and coming from the Java code. So that's something that already works today in FN, but we're adding officially support for Graal within FN, and that's something that should be available in the coming days. Again, at the beginning, I told you about we want to avoid vendor locking, so we are supporting different language, but we're also trying to be a good citizen when it comes to frameworks. We are supporting Spring Cloud Function, so if you are using Spring Cloud Function, you can deploy your Spring Cloud Function on top of FN. You can deploy your AWS Lambda function on top of FN. This is something that is very trivial, except if you are using a specific API from Amazon. In that case, obviously, that's not something that's going to work out of the box. Then there's also the serverless framework. It's a framework that basically provides an abstraction on top of existing FaaS solutions, FaaS platforms, and you can take your serverless framework code and running on top of FN. So there are a lot of things that are in FN today, and given that everything is open source, you can really see where we are going to. And it's a project that is not even 1 year old. And since basically 11 months ago, when we announced the project, well, you can see that there are a lot of things going on. I haven't really talked about all the aspects which are tied to monitoring and management. At the beginning, I told you that if you are using a FaaS platform provider, you don't have to manage your function. You don't have to manage the platform. That's right. But at the end of the day, you still want to see what's happening within your function. So that's something that is available in FN. So we are supporting open tracing. We have a plugin for Prometheus, and so on and so on. You can also get metrics through the FN CLI. So there are different hooks that basically allows you to get insight of your function, what is happening within your function. So in a nutshell, FN is a container-native, cloud-agnostic, polyglot, open-source FaaS platform. Container-native, you saw that we are using Docker under the hood, and it gives us many benefits, like the ability to easily support different types of language, like the ability to allow our users to add support for their own language, those kind of things. It's cloud agnostic, so it runs in the cloud, on premises, and on a laptop. Obviously, you're not going to hit production with FN running on your laptop, but that's something that is, again, very convenient to develop your function. When your functions are ready, you just need to basically switch context. So you do an FN use context, you give the context of your cloud provider, you deploy your function, and your function, instead of being deployed on your laptop, will be deployed into your cloud provider. So with that, I will take any question. We have like 2 minutes, I think. So is there any questions or comments regarding what we've just talked? No questions? Well, then I will just conclude with one additional thing. Well, 2 things. Some resources that you might want to check. If you just want to remember one, pick the first one, github.com/fnproject. And last but not least, fries are not from France, but they're from Belgium. So thank you.